All right. Welcome, everyone. On behalf of Understanding Ag and Soil Health Academy, we would like to welcome you to this evening's webinar on our series of building resiliency. This evening, Shane and myself are going to discuss the relationship between water, carbon, and biology. We ask that you please keep your devices on mute until we get into the question and answer segment. If you have questions at any time during the presentation, please click on the Q&A link at the bottom of your screen and type your question in. When we're finished with the presentation, we'll be answering questions. So, building resiliency.
And the topic, isn't it, Gabe?
Yeah.
How do we do this? How do we go about doing this in our landscapes?
The first question, Shane, I have to ask everyone is if they're satisfied with their soils or not. So the picture that's on the screen right now, 3 PEDs of soil, obviously. 1 PED was taken from a farm that uses a very diverse crop rotation. They grow at least 10 different annual crops. However, between the cash crops, they always grow cover crops. They do some tillage, no livestock integration. Another one of the PEDs is from a farm that has a very limited crop rotation. They basically only grow 2 different cash crops, no cover crops, no livestock. They do use tillage. The third PED is simply from the edge of a field. It is driven over by equipment, maybe grazed by wildlife occasionally. No management thought given to it, though. So which PED is which? Well, the top PED is from the edge of the field. The middle PED is from the very diverse crop rotation with cover crops. The bottom PED is from the limited crop rotation, no cover crops. You might say to yourself, well, that makes sense. I can understand that. But the really amazing thing about this is I collected these 3 PEDs all within 100 feet of each other. They are all the same soil type. And I would claim that even that top PED is degraded from what it once was. So management cause that soil to degrade. However, just like we have degraded soils, we can regenerate soils. Take a look at these 2 soil PEDs here. On the right, look at how collapsed that soil is. It's basically like cement. There's no pore spaces. Roots have a hard time penetrating. Water's not going to infiltrate into it. The soil on the left, obviously very well aggregated. You can see a lot of roots, easy for water to infiltrate, easy for air to get throughout the soil profile, easy for roots and biology to move throughout that profile. The amazing thing about this, go ahead, Shane.
You know, just point out to the attendees, when we talk about aggregation, what are we actually observing in this photo?
Yeah. We're
because
observing,
too often, go ahead.
Yeah, if you can see my cursor on there, are you able to see that, Shane?
Yes.
Yeah, you know, each one of these is a soil aggregate, and we're going to discuss that this evening, the formation of these aggregates and how important it is for us as farmers and ranchers to focus on them. So the soils in the picture here, the soil on the left was taken from one of my fields. The soil on the right here is taken just literally feet away in one of my neighbor's fields. And believe it or not, they have been no-till for over 10 years. So oftentimes people think, well, I'm a no-tiller. I'm doing what I can for soil health. Really? Okay. There's a lot more to it than that, as we will discuss. I want to start out by saying the greatest roadblock to having a resilient farmer ranch is your mindset. You know, it's up to each of us as individuals to understand what needs to be done in order to work with nature and build that resiliency. We need to take a look back and look at the historical ecological context of our own farm or ranch. So if you can imagine back to what your farm or ranch was like centuries ago, okay, before it was changed so much by mankind, it's amazing to think of how it's changed. Where I'm at in the northern Great Plains, there was large herds of bison, elk, there was deer being moved across the landscape by predators. What the result of that, those animals grazing, moving on, leaving long recovery periods, was a very healthy soil, a healthy functioning soil ecosystem, and ecosystem in general. I wish I had this map for all the United States, but this is based on soil scientists' estimates what the soil organic matter and soil carbon was like in the Great Plains centuries ago. So where the red star is, that's approximately where I'm at, Bismarck, North Dakota. You can see organic carbon was at about 7%. Well, organic matter is 58% carbon, soil organic matter. That means we were at about 12% soil organic matter in this part of the northern Great Plains. And surprisingly enough, quite similar to where Shane was at down there in northeast Kansas. Shane, you want to add anything?
No, I think that's, putting things back in historical context is significant of what these soils once were. And, let's face it, a lot of these systems now, are fairly degraded. Even our own systems are degraded. And, I guess the question begs, and we need to discuss and talk about within this presentation, is why do we accept a degraded resource? And how can we enhance it?
You're absolutely right, Shane. Those of us at Understanding Ag, we have the good fortune, we're on hundreds of farms and ranches all over the world. And I tell people that I have never, ever been on a single farm or ranch, including my own, that's not degraded. I mean, just look at that. People, Iowa, Illinois, Indiana, Minnesota, they brag about their great soils, yet those soils were once 12 to 15% organic matter. Well, we're nowhere near that today. There's very few of these areas remaining today. You have to look long and hard before you find one like that. Why? It's because of scenes like this. This was taken in western Kansas. Look at the amount of soil erosion blowing off those cropland fields. I mean, that's a travesty. Why would any producer allow that to happen on his or her farm or ranch? This is a video, April 6th, 2016 in Texas. Look at the amount of soil erosion. Here we are, these two photos. There's a lot to be learned from these two photos here. We have the Dust Bowl, the lower right, April 14th, 1935. That photo was taken in Colorado. On the left-hand side, Colorado, January 12th, 2014. Why have we allowed this to happen as a society? Why have we as farmers and ranchers allowed this to happen? Now, Shane, there's something else striking about this photo, and I know you know what it is. Why don't you talk about that?
Oh, one thing that sticks out is the bottom right-hand photo from 1935. Look at the darkness within that soil, and look at the photo to the left from 2014. And you don't see that appearance of color. So what's missing within those two photos? Why is one darker? And why is this other one from 2014 a lighter color? I mean, Well, what's missing is the carbon that was once within that soil, now is degraded. Now we're basically blowing, particles of silt, sand, and clays. Before we were blowing those same particles, but with carbon attached to it.
Yeah. And Shane, how many times as a consultant have you been out on a farm or a ranch and they have made this statement to you? But Shane, you don't understand. My soils aren't like that.
Well, almost every occurrence we go out. But, irregardless, and we'll go more into this conversation later, but, it's all about the principles. The principles apply no matter where you're at within your landscape.
Correct.
Gabe, it's just not wind erosion, but it's also soil erosion due to water. Why are these soils? This is another fine example of a long-term no-till field. No water infiltrating into that soil. So basically, the moisture that was received, or we were blessed with, is now all running off. Not only is that running off the water, but also the nutrients and soil. And this is where it ends up in our watersheds. I mean, this is a great picture Ray captured. I think this is the Snake River in Idaho, showing all the sedimentation within inside that river. It's coming from our agricultural lands. And I think we as producers, we got to start acknowledging this. How do we go about, curing this, helping these systems? Not only is it hurting us economically, but look how it's affecting our communities. Either through the sedimentation load or nutrient runoff. There's unintended consequences that are occurring on multiple levels. Just this past summer with our project down in South Central Kansas, it was just stunning to me that the amount of tillage we've seen reoccurring, and we've got to understand, when we disrupt this soil, we're disrupting an ecosystem below the soil. And how it's this ecosystem that really helps build a lot of this, with all these processes we'll be talking about here in a few more slides. But tillage is extremely destructive. And it's also no-till. I mean, if no-till is not utilized properly, and this is another example of a no-till field, long-term no-till. But, as you can obviously see, these soils are pretty plated. They're pretty collapsed. So what happens, Gabe, when we do get blessed with a 2-inch rainfall? How much of that moisture are we capturing? We can see the platedness here.
Very little. It's going to run off, the majority of it.
These soils are extremely crusted. So, this all goes back to management. This all goes back to our understanding. And there's another example of that same field. I mean, not much soil structure, pretty collapsed, and very exposed soil. Not only are susceptible when we get water, rain, how much are we infiltrating, but look at all the heat we're absorbing in those bare soils. This was taken this last summer, in fact, late July, early August, but this is basically a field with very little cover, armor on top of it. And this was taken about 2 or 3 o'clock in the afternoon, but 146, almost 147 degrees soil temp. What's happened to all of our moisture? Where's it going? Is it infiltrating in our soils, or is it evaporating away?
It's important to remember, Shane, that at 100 degrees soil temp, that plant is basically shutting down. What are we in the business of doing? It doesn't matter if we're a farmer or a rancher. We need to grow plants. Well, it's in our best interest to keep those soil temps optimum for plant growth. At 100 degrees, that plant is shutting down. The moisture is being lost to evaporation. And then when you start getting temps higher than that, you're starting to kill biology. You're having a negative effect on the very biology that's needed to cycle the nutrients that puts dollars in our pockets. Why would any producer allow this to happen on their own fields?
You're absolutely correct, Gabe. And one thing we don't look at, how's this affecting us economically? You know, this is a test we normally do when we do every time we do a consulting. We do a water infiltration ring test. You know, and it's a simple test any producer can do. 6-inch diameter ring driven in the soil 3 inches deep, 444 mils of water, and time it and see how long it takes for your water to infiltrate within your soils. And this is the prime example. Way too often when we do these tests, we see water not infiltrating. It's laying there on top of the soil surface. So these are a lot of these photos are in brittle environments where moisture is precious. But how much of that moisture are they actually really capturing? And this is a photo that I took. This is what my infiltration ring looked like after we started a project in South Central Kansas, General Mills, the wheat project. You know, that's sandy loam soils. And basically I ruined an infiltration ring and broke multiple blocks trying to drive this ring into the soil to do this test. And it just shows the destruction. I don't think we acknowledge, you know, how collapsed some of our soil systems really are. So now we dive deep here. I'll let you start, Gabe.
Yep. So it all goes back to the 6 principles of soil health on the left there. We use those 6 principles to drive the 4 ecosystem processes. No matter where we go, doesn't matter where in the world we are, these are constant. The 6 principles drive the 4 processes. We have to keep these in mind. We have to memorize them. Every time we walk into one of our fields, into one of our pastures, we need to have this running through our mind. How are the 6 principles being applied here? And are the 4 processes occurring on this particular piece of ground?
I think we need to spend just a little bit of time here going through. I know we talk about this, you know, the principles multiple times a day with individuals, but I think we need to take some moment here and explain what context is and the rest of them. So basically context is, I mean, that's basically every individual's why. You know, your context could be spiritual. Your context could be your family. Context could be economical. Or your context may be your community. Or it could be a combination of all those. So basically, the way I interpret context is what's your driving force? What's going to motivate you every day you walk out that door to implement these principles? What are you observing and how do I implement them?
I would just add to that, Shane, another context is we all have an ecological context. Where is our farm or ranch located? Are we farming or ranching in our ecological context? And I'll use myself as an example. It takes me a long time to grasp things. For years and years, I calved in January and February in North Dakota. That is plain stupid. That is out of context. There's no deer, there's no bison dropping their calves or fawns in January and February in North Dakota. That's out of context. Now we calve in late May and June, game changer. We're calving in context. I'll use another example. You come into central North Dakota now, you would think you were in one of the I states. All you're basically going to see is corn and soybeans. Okay. We're in a cool season environment. What are corn and soybeans? Now, I'm not saying at all don't grow them, because we do have a small percentage of warm season components in our native rangeland. However, they're comprised of 70 to 80% cool season. Yet all we see grown as cash crops are corn and soybeans, warm season crops. That's out of context with the environment.
Those are great points, Gabe. And, you know, the next principle is least amount of disturbance. You know, and what we're communicating here is, you know, try to implement no-till practices. Minimize that soil disturbance as much as possible. I mean, nature didn't do a lot of mechanical disturbance as we do in production agriculture. So least amount of disturbance is referring to implementing no-till practices.
It also, Shane, refers to chemical disturbance, synthetic fertilizers, pesticides, fungicides, herbicides, and even organic nutrients. You know, we work with a lot of organic producers, and many are using feedlot manures and manures from lagoons, from animal confinement operations, etc., maybe poultry litter, but they're using it in amounts that are in excess. And that's actually having negative ramifications on the soil ecosystem. So we need to limit all those disturbances.
And we'll talk about that, you know, those synthetic stuff when we talk a little more about the biology. You know, armor. You know, Gabe, what does armor mean to you?
Now, armor to me, it's like our skin. It's a protection. On my ranch, I never want to see bare soil. If I see bare soil, I know that my management has allowed that to happen. And I know the negative ramifications of bare soil. We need to protect that soil from wind erosion, from water erosion, from evaporation. We need to provide the optimum habitat for that soil biology and that plant.
Absolutely. You know, the next one is diversity. And, you know, that may be a little confusing to some folks, but, you know, as that photo you showed just a little bit earlier, that perennial grassland system, it wasn't a monoculture. It was diversity of plants. You know, these diversity of plants, you know, they're capturing energy, solar energy, but they're also, and we'll talk more about this, and we've got some good illustrations, you know, basically putting different carbons in the soil to feed different microbiology, to attract different microbiology. So it's the diversity, you know, we work well within diversities. Nature has always functioned with a diverse system. You know, nature's never worked within a monoculture. So how do we implement that diversity into our, so let's just talk about this real quick, Gabe, while we have a moment. So if I'm a producer, let's say I'm a producer up in North Dakota, how do I implement diversity into a cropping system?
Great point, Shane. And the way we do that is you take the producer where they're at in their context and work with that. So we try to diversify the cash crop rotation. One of the many beautiful things about North Dakota is we can grow a wide array of different cash crops up here. Spring wheat, oats, barley, sunflowers, peas, dry edible beans, you know, corn, safflower, lentils, and durum wheat, and the list goes on and on and on. We need to diversify that cash crop rotation. Now we're in a cool season environment. As I said, we want to be strong on the cool seasons, but we do want to implement a warm season component. And often how we do that is by taking an early harvested cash crop of a cool season, then follow it with a warm season cover crop mix, such as sorghum sedan grass, millets, cowpeas, buckwheat, species like that. And that way we can get the diversity of plants feeding soil biology, that diverse array of all these carbon compounds.
So, you know, living roots, you know, as you just stated, feeding compounds to the microbiology. Well, that's the reason why the purpose for living root is we want to be capturing photosynthesis, carbon, and feeding that into the soil microbiology at all times. So even when we do a lot of annual systems, and that's the reason why cover crops are kind of important in cropping systems, is to get that living root back in place, help to feed that soil microbiome. And, you know, on the last one, I know the one you and I really utilize is animal integration. You know, animal integration, one thing, and I'll let you discuss further, but it gives us an opportunity for an economic gain, you know, to capture revenue. You know, the next thing is the animal integration allows for, you know, basically to move soil microbiology throughout those systems through the grazing aspect of the manure and urine in these systems. You know, and we can also look at diversity with inside animal integration, diversity of different animal species within these systems. Because, you know, we too often say, well, you know, we just want to put cattle out there. But, you know, we need to take consideration some diversity within that aspect too in the animal integration.
That's exactly right, Shane. And I would add to that also insects. You know, I put together a presentation once on kind of Gabe Brown's aha moments and people I met that I learned from something from. And I distinctly remember the first time I heard Dr. Jonathan Lundgren tell me that for every insect species that's a pest, there's approximately 1,700 that are either beneficial or indifferent. They're not going to help you or hurt you. And I got thinking about how ridiculous is it of mankind to spend all its time and attention focused on killing a pest when there's all these beneficials. We should be spending our time, how do we provide the home and habitat for all those beneficials? Now, absolutely. Shane, the 4 cycles we're going to get into here as we move along in the presentation: the energy cycle, the water cycle, the mineral cycle, and then community dynamics, or as some people call it, diversity.
The power of sunlight. So, I mean, we all capture sunlight within our systems. So how are we harvesting that sunlight? Do we have a living root out in that soil with a leaf structure? And, you know, this is a great little image here. You know, it's showing, we can obviously see, if we think about the principles we just discussed, we've got some armor on this soil. But now we've got a living root back in this soil. So this plant is taking sunlight and carbon and creating vegetative growth. But in that process, it's also that carbon's being fed back to the soil microbiome. And if you look along these roots, the rhizospheres, look at those sheaths of microbiology that's adhered to that root. And basically that bacteria is starting to build the process of the water cycle. So as we talked about, it's the principles that drive the processes. So the first process is, are we capturing solar energy? And in this image, yes, we are. Are we maximizing it? No, but we are capturing some. Now, are we starting to build a water cycle? It looks like we're starting to build aggregation. And the next thing you need to ask yourself, are we starting a nutrient cycle? And then that rhizosheath that we just showed of that biology along that rhizosphere, this is what this biology looks like. Now, what's remarkable about this photo is this is one drop on a slide with one view underneath the microscope at about 200 magnification. So this is just one spot on a slide at 200 magnification, but look at the abundance of life. You know, look at the testate amoebas there. They are the ones that are driving the nutrient cycle. They're consuming those little small circles there. You see it are kind of clear. That's bacteria. They consume those bacteria. Those bacteria are very nutrient dense. But in order to capture those nutrients and cycle it back, we need something such as a predator like the nematode, protozoas, microarthropods consuming them. And this image here, this is probably one of the most powerful images, you know, we can illustrate. This is basically liquid sun, roots leaking exudates. Exudates are basically your sugars, you know, carbohydrates back into the soil, feeding the microbiology. But this is a plant. This is how the communication works with the plant and the soil microbiology. The plant's sending out chemical compounds to attract microbes to provide it nutrients, but in return, the plant's going to provide it nutrient also in the form of carbon.
The amazing thing about that, Shane, is the plants have the ability to send out these compounds to attract biology to bring it specific nutrients.
Exactly. So this is an incredible video and just shows the power of life. I mean, harnessing solar energy, carbon, and feeding that. This is just another great illustration of these predators that are consuming, feeding on the bacteria and the fungi within our soils. This is a water bearer.
This actually does a good job, Shane, of illustrating the importance of water
hydration
in biology. Yes. Biology lives in and on thin films of water between those pore spaces of those soil aggregates. This is a water bearer, and it is swimming in your soil in water between those pore spaces.
So you bring up a great point there, Gabe. You know, when we start talking about these processes, each one of them's got to go hand in hand. You know, the first thing is we've got to have the bacteria come in first and start feeding along the rhizospheres. The bacteria are what build the microaggregate, but then we need the fungal community to come along and help create the macroaggregate. Because as you just stated, this biology, especially our predators, they swim on the films of those waters. That's how they become mobile. But you know, if we're just dealing with sand, silt, and clay, without the biology, that's what we have. But all of us have these properties existence in most of our soils, a combination of these. So how do we take the sand, silt, and clay and turn this into productive systems? Well, we got to start building the biology. And this is a great example. This is a microaggregate that's being built along the rhizospheres. Gabe, you can see that. Those larger images, circles, those are the microaggregates that are being built by the bacteria and some fungi.
This photo is courtesy of Dr. Chris Nichols. This is actually a millet root here from a millet plant. And that's, as Shane said, that's new aggregates being formed. Those sands, silts, and clays are being bound together. I can't tell you how sometimes challenging it is to get producers to understand the importance of this. Their farm profitability depends on this.
But it also starts with, we've got to capture energy. We've got to start building these water cycles. And here's just a great illustration. This is a pine seedling, and it's showing the rooting system of the pine root itself, the plant, but it's also emphasizing the mycorrhizal relationship this plant has. So look at how many 10 times more soil volume the biology is helping that plant seedling, pine plant seedling capture of nutrients. And not only nutrients, just water. Think of the aggregation that's occurring along that pine seedling. And if
so
we just look at those,
this is the main root to the pine seedling, obviously. Then all this is the mycorrhizal fungi that's formed in association with the root of that pine seedling. Think of it as the streets and avenues of the soil. It's moving nutrients and water from a much greater distance. Realize our plants, they can't move, obviously. Where they germinate and grow, that's where they're going to stay. So they depend on mycorrhizal fungi. Yet, what do we do so often in agriculture? Well, we use tillage, we use high rates of synthetic fertilizers. That destroys mycorrhizal fungi.
Absolutely. You know, I see that image every time, Gabe. It looks like the lungs, you know, helping build not only water infiltration, but it's also helping provide oxygen within the soil. You know, this is just another great example, illustration of the fungal community. You know, you can see the root of the plant they have illustrated here, but look how the fungal hypha is helping increase the volume, you know, the nutrients that plant now can capture with that association. But it all starts with capturing solar energy, sunlight, and starting to build the water cycle. You know, a fungal component we talk a lot about is mycorrhizal. So it's the mycorrhizal, you know, it's making association with the plant root itself. And the mycorrhizal, you know, it produces a glues called glomalin that helps stick the sand, silts, and clays together to start building this macro aggregate within the soil system. This is what really starts increasing, driving the water cycle. And then the nutrient cycle follows behind that. You know, mycorrhizal fungi help to build the macro aggregate. And this is a great example of a soil that's very, very well aggregated. You know, so think of it this way, you know, if you were having to move through concrete, if you had a concrete slab, how easily could you move through that concrete slab? You wouldn't. And that's what a lot of our soils that we observe look like. But when I have this aggregation, if I'm a nematode, microarthropod, water bear, whatever it may be, a predator, I can now swim along those aggregates to get to those rhizospheres to consume bacteria and fungi in order to help cycle nutrients. This is what drives our nutrient cycle.
Also, Shane, think of how easy it is for roots to penetrate how deep they can go in this soil, and then also the air movement throughout this soil profile with soil that well aggregated.
You know, we underestimate the power of biology, you know, and as you made an example there on the roots, you know, most plant roots can only break about 300 pounds of compaction, but it's this fungal, they can break up to 1,100 pounds of compaction. So even if you got very collapsed soils, very compacted soils, you know, we start building back the biology, we can build those aggregate structures. And it's just another good example of showing how the mycorrhizal, you know, is helping with nutrient uptake. You know, it's capturing amino acids, nitrogen, and drawing that back into the plant. You know, the amino acids are bringing back in, you know, so the plant doesn't have to take up a nitrogen molecule and break that nitrogen molecule down in order to make amino acids. It can bring these amino acids in through the mycorrhizal hypha, feed it back into the plant root, and let the plant assimilate proteins from the amino acids. So it's a lot less work for the plant.
I would just add to that, Shane, and this also shows why the vast majority of soil tests being used today are not sufficient. They're only showing us the inorganic fractions of nutrients. They're not showing us the organic fraction. And plants, through their association with mycorrhizal fungi and biology, have the ability to use some of that organic fraction of nutrients.
Absolutely. You know, when moisture becomes limiting in a dry land period, the mycorrhizal plant utilizes the water stored in the root cell vesicles. And this is just a great illustration, you know, and we're dealing with some major droughts throughout the United States. You know, we have the association with mycorrhizal, you know, we've seen that pine seedling, how that's expanding the roots, you know, nutrient zone, but also capturing water and feeding water back to the plant with this association. But Gabe, you know, this is how soil should function. You know, we should think of our soils as a jar of marbles. So if I would pour a quart of water on the top of those marbles, would that water just sit there on top, Gabe?
No, it would immediately go start filling in this case, the jar, or in the case of our soils, it'd fill a soil profile. Take a look at the aggregation of this soil. Imagine a rainfall event. How much water could infiltrate? Now, Shane, I know that you and the rest of the consulting team at Understanding Ag do a lot of water infiltration tests. How much water can normally be infiltrated in what you're seeing on an average in an hour on many of the fields of the clients we work with?
Oh, we're probably lucky if we can do an inch an hour.
Yeah.
But what's amazing, Gabe, is we can usually find a location within inside that farm and ranch where we can infiltrate many inches an hour, you know, and we go back and we show those individuals, those farmers and ranchers, you know, how many principles are in place in those areas where we can infiltrate 5, 6, 7, 8, and up to 10 inches of water. You know, well, we talk about the principles. What's occurring there that's not occurring out in their pasture system or the row crop system? And how's that driving the processes?
Right. So we must capture solar energy then to feed biology and drive the water cycle. So they're all very intimately related and they rely on each other. It's kind of like the chicken and the egg. We need to be paying attention to, and as Shane said, applying the principles to drive the processes. I'm going to show you a series of slides here. I took these photos when working with a client in New Mexico. And this client was telling us that, well, you don't understand, our soils are this white type soil that just very poor water infiltration, no aggregation. And I got looking at it. And so you can see here where I got my cursor, I dug a little spadeful there where there was no plants growing. And then I simply took 2 steps away and dug soil from near a plant. Here are those 2 soils. I moved this was near a plant. This was from this hole here, no plant around it. And I asked him, now, are you going to tell me that the soil type changed in those few feet? Well, obviously, they were a bit taken aback by that. What's the difference between here and there? The difference is the plant, the living root, energy cycle out of the atmosphere into the soil, feeding biology, building soil aggregates. Look at. So anybody who's listening to this webinar this evening, if your soil is not what you'd like it to be, please go look in a mirror, because you're the reason for that. Okay? It's a lack of applying the principles to drive the 4 processes that leads to desertification. Now, Shane, if we'd look at historical ecological context, tell me what New Mexico was like 400 and 500 years ago. I know you were around then, so please tell us.
Well, let me go back and find my diary here, Gabe.
Yeah.
No, I mean, it was a vast, very diverse grassland system. I mean, we're not trying to communicate here that it was a very, very extremely wetter environment, which I do feel that it was. It was still probably a fairly brittle environment, but with that diversity and the soil microbiology, you know, and we think about how the principles were being applied then, you know, it had animal impact, you know, there had minimal disturbance, you know, and it always had a living root.
Yeah.
You know, that's what helped build those systems. And what's amazing is these systems can be rebuilt back. We witness it, we see it.
Just like we took soil that I believe in New Mexico was much better than this, then it went to this, then it went to that. We can move it back the other direction. Here's just those, this is courtesy of Kim Barman, one of our board members of the Soil Health Academy. She took degraded soil and then much healthier soil to illustrate to people that the choice is yours. Your farm, your ranch is a direct reflection of you. Ray Archuleta said it best. You know, Ray had a brilliant idea pop in his mind this one time. And he said, plant and soil are one. And they really are. You know, we cannot have healthy soil without living plants. This is simply how nature functions. And Shane, you just mentioned that. Very diverse ecosystems, that's the community dynamic process. Energy cycle, mineral cycle, water cycle, community dynamics. That is how nature functions.
Before you move off this slide, you know, for our participants to understand what we're talking about, you know, when we talk about the processes, and the first thing observation we're looking at is how much energy is being leaked in this system right now. So if we was to stand there and look, you know, there's probably no sunlight hitting the soil surface. Look at the architecture of all the different plants, vegetation that's out there capturing all that solar energy. And as we talked about earlier, it takes that in order to help start the water cycle. So think about the diversity now of the water cycle starting to function. As we get this water cycle functioning, now we have the nutrient cycle, basically the predator-prey relationship working. And as you communicate, it's the community of dynamics that's functioning within this particular photo.
That's exactly right, Shane. Different leaf sizes and shape. Our goal on our farm and ranch should be to not allow any sunlight to hit the soil surface. It needs to be intercepted by a leaf of a living plant.
Like, Gabe, what happens if we're just a row crop individual?
Yeah, we can do this also. Okay, take a look at the biomass there. That animal standing there is a 1,200-pound grass-finished animal. So that'll give you an idea of the height. And I will tell you that that field that's being grown on had, this photo is a few years old, but it was 12 years of zero synthetics of any kind. It was 25 plus years of no-till on that particular field. Very diverse cash crop rotation on there. We were having an economic gain from the cash crops, but then we're also planting cover crops on there. This is a diverse warm season mix. Obviously, sorghum sudan, pearl millet, several kinds of millets, cowpeas, etc. And then we're applying the principle of integrating livestock onto the cropland. It's a shame now that you can literally drive for hundreds of miles through many states in the central and eastern U.S. and not see a fence. You don't see livestock out on the cropland. And meanwhile, we have farmers complaining, not so much this year, but complaining about prices. They're missing an economic opportunity, but they're also missing a real opportunity to advance the health of their soil ecosystem. You know, we often get asked, well, can you have healthy soil without livestock? Yes, we can advance soil significantly without livestock, but the soil will never be as healthy as where we are able to integrate animals.
And you're absolutely right, Gabe. It's the livestock helping move that microbiology. It's also the livestock putting down a lot of that armor, litter, you know, and so livestock are also taking those nutrients that are tied up in that vegetation that are immobilized, and with the consumption of it, remineralizing those nutrients back into the system. So this is just a great example, you know, of where you've utilized animal impact. You know, you're applying the principles, you're driving the processes, you know, and the results are, you know, you're capturing economic gain with those individuals, animals. But this is a great example of armor on the soil. You still have a living root, minimal disturbance, you know, animal impact, you know. So that's one thing we need to start training ourselves to. When we walk out the door every day, of how many principles are in place, what's missing, and sticking that shovel in the soil and seeing, observing, what does that soil structure look like? Do I need to influence it a different way? You know, a lot of that nutrient cycle, you know, when we go out and really put a lot of synthetics nutrients out there, you know, we got to remember within a healthy soil and a teaspoon of it, there's billions of microbes, mainly bacteria. You know, that bacteria is going to utilize that nitrogen source. Well, the problem is when that bacteria utilizes that nitrogen source, it's tied up, it's immobilized within their bodies. So in order to cycle that nutrient, you know, we need something to come along and feed upon them. And this is just a great example, you know, of an air bubble, you know, with protozoas feeding along the side for bacteria. So just look how many hundreds, if not thousands, are within that one image. You know, this is another great example. This is a bacterial feeding nematode, you know, eating bacteria. All that black stuff there within his gut there, that's bacteria. So basically he's consuming that bacteria, which has nutrients immobilized, and through the consumption of the bacteria by the nematode is now mineralizing that, making those nutrients now plant available. You know, and this is kind of gets into, most people think this is a pretty complicated subject matter, you know, nitrogen mineralization. And, you know, we try to make it fairly simplistic for everyone to understand. So when we start talking things like carbon to nitrogen ratio, you know, we got to understand, you know, what we mean is the bacteria there you're seeing to your left has a carbon to nitrogen ratio of a 5:1. So 5 parts carbon, 1 part nitrogen. But over to the right, this nematode, this bacteria feeding nematode, has a carbon to nitrogen ratio of 10 parts carbon and 1 part nitrogen. So what's going to happen when that nematode consumes that bacteria? How many bacteria does he need to consume in order to meet his carbon to nitrogen ratio? Well, the nematode needs to consume 2 of those bacteria. But now he's got also extra nitrogen within his system. So what's the bacteria, or the nematode going to do with that excess nitrogen? Well, it's going to excrete it out. And from that excrement, it's going to make it now nitrogen plant available. It's not just nitrogen, it's also phosphorus, potassium. It's all the other nutrients our plants need. So it's just not the nitrogen itself. And this is a great little illustration. I'll let Gabe allude more on this.
So this is courtesy of Walter Lynn. He sent me this. You can do what's called an underwear test. So you take a new pair of cotton underwear, you bury it in the soil, shallow, for 60 days. And Walter did this. On the right-hand side was underwear buried in healthy soil. On the left-hand side was a conventional Illinois cornfield. Take a look at the difference. How much biology did it take to consume those underwear on the right? Yet, how little biology is there in many of our agricultural fields today? Basically,
you want to make sure, Gabe, if you do this, we need to make sure we're using cotton underwear, not your silk ones. Yeah. So just make sure we bear that in mind.
That's right. But Shane, we always hear this, but we have to fertilize, right? We hear that over and over again. What you just explained to us about that nutrient cycle and nematode eating the bacteria, but you don't understand, Shane, we have to fertilize. Well, one of the tests that Understanding Ag now utilizes regularly with our clients is we do what's called a total nutrient digestion. So we'll go take soil tests down to a 12-inch depth. And the reason we're doing this is we want to be able to show our clients just how much nutrients are really in their soils. So think of total nutrient digestion as the soil's bank account. It takes into account not only the inorganic fraction, which is what most soil tests being used today will show you, but it also takes into account the organic fraction. Now, as we discussed earlier, through mycorrhizal fungi, plants have the ability to use some of those organic nutrients. Well, why isn't your agronomist telling you that then? So here was some work done by our consultants, Michael Thiele and Blaine Jurtis and Kent Solberg with our General Mills Regenerative Ag project in Manitoba, Saskatchewan, and North Dakota. We tested for all of these nutrients you see on the left-hand side of the screen. Here's what we found. The average on those 45 farms, there's 9,000 pounds of nitrogen in the top 12 inches of the soil profile. Okay, how many of your agronomists would be telling you that you have 9,000 pounds of nitrogen there? Well, you do. And Shane, we've done this test on literally hundreds of farms, ranches all over North America. We have not found a single one that's deficient. Isn't that correct?
I don't think it's deficient in Gabe's biology.
That's exactly right. Phosphorus, the average, 2,300 pounds. Mind you, this is only in the top 12 inches. How deep do your plant roots go? They go a lot deeper than 12 inches, I would hope. Look at potassium, 11,000 pounds per acre. On down the line we go. Look at these micronutrients. Look at iron there, 60,000 pounds. Fact of the matter is, as Shane said, we are not deficient in nutrients. We're deficient in biology, which means we really need to become intentional, right? As farmers and ranchers, as stewards, in order to make a profit, we need to be intentional. In other words, we have to be deliberate and we have to have a purpose. Your farm, your ranch is a direct reflection of you. And I'll show you how deliberate Gabe Brown is about this. Drove me nuts that my wife would insist on mowing our lawn. To me, that's not regenerative. So this is how we mow our lawn now. For the last 6 or 7 years now, we do not mow the lawn with a lawnmower. We bring our cattle in and let them graze. Just, again, context, Northern Plains, we need long recovery periods. So we're doing this once per year. We started out with a monoculture lawn of basically crested wheatgrass. Now I've counted over 30 different species of grasses, forbs, and legumes growing on our lawn. The only issue now is my wife's mad because there's so many bees because of all the flowering species. So goes to show that some women are just hard to please. Oops.
So, well, you started a new landscape business here, Gabe.
Yeah,
of lawn grazing.
Right. That's right. Yeah, notice the birds flying above, the cowbirds. Yeah, so that's what I mowed, fertilized all in one pass. That's being intentional.
Not intentional-ish. You know, it's just a great image. You know, never pass up the opportunity to capture sunlight. And that's the reason why, you know, when we talk a lot about cropping systems, you know, of implementing cover crops, changing your disruptions. You know, we too often we get into these corn soybean rotations, especially in my part of the world. You know, we need to start looking at how do we, and we're limited. I mean, harvest is occurring right now. We're almost to the 1st of October. We're going to be very limited in the diversity we can plant. But what we can start looking at is maybe adding a biennial, a wheat crop, some type of a cereal crop, and then harvesting that come next June, then coming in and putting a very, very diverse mix in. You know, how much solar energy is being leaked in that system right there in this photo? Very little. And all that different leaf architecture.
Yep. This photo, Shane, was taken October 5th on my ranch. We had already froze multiple times, yet look what you see there. That's a pea plant there flowering that didn't freeze, even though I'll guarantee you we had at least 15 frosts on that occur before I took this photo. You can actually lengthen your growing season by having a healthy soil. And then we hear this over and over, Shane, that, well, if we plant a cover crop, it's going to use all my moisture. In the foreground here, I had harvested a cash crop. I immediately went in with some bin run oats, some bin run peas, some triticale, and 2 pounds of daikon radish, not with the intention of grazing, but with the intention of capturing solar energy. So was I worried about it using all my moisture?
No. You know, and obviously, you know, we got to start the processes. You know, is it going to flip overnight? You know, that's when we talk about being intentional, not intentional-ish. You know, you've got to be applying all the principles. You know, and those principles, as we've stated earlier, are going to drive the processes. You know, and that's what you're doing in that last image. You know, it's from implementing the principles, driving the processes, that you're able to do that in your environment. You know, the water cycle depends on plants. You know, it's the plants, you know, providing the carbon to the microbiology, and in return, the microbiology building the aggregate structure. That's what's going to help with water infiltration rates. We can't do this with mechanical tillage. We can't do this with any kind of engineering. It's all done with the soil biology. And I'll let you talk about this particular photo, Gabe.
Yeah, so I took this photo. This is a neighbor of mine. Every year he goes out and he tills this low spot here. No tills all the rest of his field, but tills this low spot. And yet every year we'll get a rain event and there the water will sit and won't infiltrate. And in my mind, I'm sorry, but that's the definition of stupidity, doing the same thing over and over and expecting a different result. When a ½ inch of water cannot infiltrate, that's utterly ridiculous. You must have well aggregated soils, as we said earlier, in order to get that water to infiltrate. Shane, do you agree with this statement? The amount of moisture one receives is irrelevant.
Yes, Gabe, I agree with that 100%.
You're absolutely right. It does not matter how much rainfall you get. What is relevant is effective rainfall. In other words, how much can you infiltrate into your soil and then store in your soil? In order to be stored in the soil, we must have the carbon. In other words, remember, soil organic matter is 58% carbon, to store that water, okay? On the spade there that I'm holding in this photo, that's my soil on the spade. That's the neighbor's 10-year no-till PED right at the forefront of this picture, okay? Which is higher in carbon, which is going to be able to store more moisture. For every 1% increase in organic matter, soil can hold up to 27,000 more gallons of water per acre, okay, in each foot of the soil profile. So look at that. If we increase our organic matter levels 2 or 3%, what's that going to do for our resiliency? I will never forget, Shane, when our consultant Alejandro Carrillo gave a webinar on our series. And as a matter of fact, Alejandro is going to be giving a webinar on October 27th or 28th. And Alejandro was telling us, he was asked the question, well, how much rainfall do you get, Alejandro? And he said, well, between 6 and 8 inches annually, but I really don't need that much. I will never forget that. So think of if you increase the organic matter in your soils 2 to 3%, look at what that would do. Look at the extra water holding capacity you're going to have in your soils. It's going to make you very resilient. Right.
I mean, how many producers have you ever talked to besides Alejandro that ever make a statement like that? You know, but also think when that water is escaping your system, the nutrient loss, the sediment loss, you know, roots build organic matter and cycle nutrients. And this is just a great example of a prairie system. You know, we talk about the architecture above ground, but look at that architecture of rooting systems below the soil surface. Look how that carbon layer is being pulled down the soil, the aggregation that's occurring, you know, and think about the water holding capacity of this system and think about the water holding capacity of your system.
And look at this photo, Shane, the different root structures. You have fibrous root systems from the grasses, you have tap roots from the forbs, tremendous diversity. That's the community dynamic process.
And this is just a great illustration of this wheatgrass here. Look at the rooting structure of that grass. You know, we often sometimes get way too hung up. We think this is a nitrogen deficient system we're dealing with. It's not a nitrogen deficient system. It's a carbon deficient system. Think of the amount of biology that's being fed by that individual plant. Look at that root system. Think about all the carbon that's being supplied, feeding biology. You know, that's just an incredible photo. You know, and this is what we all ought to be striving and achieving. Look at the rooting depth of that.
I want to talk a little bit about the livestock integration, the sixth principle, and we call it adaptive multi-paddock grazing, the power of stock density. You know, it was known, historically speaking, that bison roamed all of the lower 48 states and up into Canada and into Mexico, and elk and deer and antelope and bighorns, and the amount of grazing ruminants was tremendous. The numbers of them, I should say. And they kept together for protection from predators. And that helped to build these healthy soils. Well, we're missing that in agriculture today. Instead, with the invention of barbed wire, we went to paddocks, set stock, leave them in for the entire season. That's the degradation that we've seen over much of our rangelands. So we have to use ourselves as the proxy to these predator animals, and we need to move these animals. We need to take advantage of livestock as a tool. This is a great photo. Thank you for Michael Thiele for passing this on. This, a client he works with in Canada, they took a cropland field and decided to do multiple day moves on part of it. And then they moved every 2 days on the rest of the field. Take a look at the differences in those soils, the aggregation, the carbon. If that doesn't show the power of livestock impact, I don't know what does.
It's a great illustration. We need to talk about just a moment there, Gabe. But when that animal takes a bite of that plant is now putting out different root exudates, different compounds to feed biology. Because what's the purpose of the plant? It's to get to a reproductive state. And the animal impact really enhances that. And this is a very great example of that. But if we overgraze it, we got to make this statement also. We can inhibit this process, where now that plant is no longer feeding the soil microbiology. It's capturing all the photosynthesis it can and carbon to grow back vegetative growth. So we've got to understand, how to, when we use these practices, how to manage them properly once we have them in place.
That's a great point, Shane. I showed the photos of New Mexico, and we talked about that it was once a vast grassland. What happened centuries ago, it was primarily done with sheep. They overgrazed, they stayed on areas too long. As they overgraze, that plant has to use more and more of the energy from its root system, and those roots get pruned and weakened and pretty soon die, and that leads to desertification, which we're seeing over vast areas of this world today. This next photo is from our friend Adam Dougherty in Coffee County, Tennessee. You can see there between the fall of 2014, that's the picture on the left, spring of 2017, by integrating cover crops into the cropping system and able to capture more of that solar energy. Look at the soil aggregation that was built. Look at the biology that comes with it. 39% improvement in the food for biology. Tremendous improvement in a very short period of time just by using these principles to drive the four processes. I'm going to talk a little bit about this photo, a series of photos here. So as many of you have heard, large areas of the Northern Plains are in a severe drought. This year, here in North Dakota, on my ranch, it's the driest year we've ever recorded. The photo you're looking at there, although I don't like to do it, I did hay off a fall biennial. That fall biennial mix was cereal rye, winter triticale, forage winter wheat, winter barley, and hairy vetch. We hayed that off the first few days of July and immediately went in with this diverse warm season mix. And how there was enough moisture in the soil to germinate it, I don't know, but I took that photo on July 17th. We had zero rainfall between that day, between seeding and the first week of September. I got to go back to this because I got to say something, This is just ironic. So we are now in our 6th year of well below normal precip here on our ranch in North Dakota. And 6 years ago, the state ag department and the state legislature were talking about how they could help farmers cope with drought. And I made the statement to them that, well, they need to start focusing on soil health. And our state ag commissioner at that time told me, oh, Gabe, you can't talk soil health. You can't kick people when they're down. And I told him, I said, if we don't start talking about it now, the next drought's going to occur and nothing will have changed. Well, would you believe, as I was seeding this field on July 5th, a certain state ag commissioner was on the radio and I was listening to it. And he made the statement, well, there's no farmer out there that's going to plant a cover crop now because it's so dry, nothing will germinate. It'd be a waste of money. Okay. So I show you this series of photos. Here's July 17th. That's, I had seeded it. It came up. Here's September 1st. We had received zero rainfall. Now that's not very tall, but what was so impressive to me is that with virtually no moisture in the soil, it stayed alive. And yes, that's not much growth there, but think of what's happening. I'm still taking solar energy, pumping it into the soil, keep feeding biology. Now, we were blessed with about 1.9 inches of rain between the 5th of September and today. And I took this photo this afternoon. That's that same field. See, I gave myself a chance by focusing on my soil ecosystem, by focusing on using the principles to drive the processes. I gave myself a chance. And now we're gonna have significant grazing from this particular field, but also think of what I'm doing for the soil. Think of the energy that's being cycled that'll be able to be used to fuel next year's cash crop on that field. Meanwhile, look in the background, my neighbors just to the south of me there, absolutely nothing growing. So people can make fun of us and say it's foolish to grow a cover crop following a cash crop, but I'm sorry, they just don't understand how nature functions. Anything to add to that, Shane?
Well, I mean, there's only one thing I can say. This just is a fine example of what being intentional can produce. I mean, it's easy to sit there and make excuses, but that's obvious what you've done. And I know how dry you've been in that northern environment the last many years, and you still have production occurring. I mean, that's incredible.
So I'm going to talk about where that leads us. On the left there, that's Dr. John Norman. Dr. John Norman is a world-renowned soil scientist. He's probably one of the top soil scientists in the world on carbon. I was involved with a project where we took 300 soil cores 4 foot deep on 600 acres of my ranch here. And we were trying to determine the amount of carbon in the cycle. What we found was that in areas on our ranch, we now have well aggregated soils down to 48 inches. We have 19 inches of A horizon topsoil where the neighbor has 3 inches. When my wife and I purchased this farm in 1991, we had less than 5 inches. Today we have 19. Take a look at that soil there, okay? We obviously have more pore spaces. That leads to more biology. That leads to higher water infiltration rates, leads to more oxygen in the roots, leads to higher carbon levels, leads to easier root access to those nutrients. That's how we build resiliency. And we can do this on any farm, any ranch, anywhere in the world. This isn't rocket science. It's simply applying the principles to drive the processes. So on the right-hand side of the picture, that's my neighbor's 10-year no-till. On the left-hand side are my soils. Which one has more carbon? Which one's going to be able to infiltrate more water? Which one has more biology? Which one's going to cycle more nutrients? Which one's going to be more profitable? We have to remember that the first duty of the agriculturist must always be to understand that he or she is a part of nature and cannot escape from his or her environment. Sir Albert Howard said that, and I think it's really fitting. So often in production agriculture today, we're trying to outproduce our environment. We're trying to impose our will on our environment. We need to work with nature, not against her. This to me is the number one reason to work with nature. We can want to do what's good for the environment. We can want to help take carbon out of the atmosphere, put it in the soil. We all want clean air, clean water. We want nutrient-dense food. But let's face it, as farmers and ranchers, we need to make a profit so we stay out on the land. And I really think that it's imperative of us to understand the principles, the processes, so we can make a profit and stay on the land, because it's not going to do anybody any good if we're not out there taking care of the farm and ranch. I want to tell you before we get to the Q&A that our upcoming webinars, our next one will be Thursday, October 28th at 7 p.m. Our good friend and consultant Alejandro Carrillo is going to be talking about the work he's done on his Las Damas ranch, ranching for resilience. And then future webinars are coming up. Dr. Ellen Williams and myself will be giving a webinar on epigenetics. And we got Burke Tykert giving a webinar on ranch profitability. So with that, Shane, I see the questions are piling up here. So,
well, I think the first one, I'll read it here, and I think you just acknowledged it in your presentation. But when you're talking about the percent organic matter, how deep do you mean, and potentially how far down can we see organic carbon deposited?
That's a great question. And so when I talk about the organic matter levels on my ranch, we took part in that study, and we took soil probes down to 4 feet. And this gets a little bit into the question on carbon sales, and should ranchers be selling carbon. What we found after all that work and all those probes and money spent is that it was really incomplete, because on our ranch, we're now storing carbon deeper than 4 feet, and we only sampled to 4 feet. So if I'm truly going to be paid for the carbon that I am cycling into my soils, we need to measure it deeper than 4 feet.
Absolutely. So Janet has the next question here, Gabe. So we can address it, and we've also got some of the consultants on the line. But those photos of the poor quality soil that exist at a no-till operation, what happened there? And the question goes on, was it just the lack of the other 5 principles?
That is a great question. David Kleinschmidt, let's call on you to help us with that one, and then we'll all chime in. I'm sure we all have some comments.
Well, thank you, Gabe. And thanks, Janet, for that question. So yeah, when we look at no-till alone was just a tool. You know, we weren't disturbing the soil surface. We were trying to save moisture, conserve moisture in that soil. But yeah, the other principles weren't in place. You know, if you don't have that living root in that system, you're not really able to build the aggregates. Now, a lot of times, and especially when you get out into the Western environments, into the plain states, where you do a lot of no-till and fallow, and oftentimes it's a chem fallow. So you're spraying herbicides to keep anything from growing on there, because there's this, I guess, thought process that we don't want to increase the weed seed bank out there in the soils, even though there's millions of seeds out there anyways, that we're going to spray it and keep it killed. So even the weeds aren't releasing any root exudates, and now we're spraying stuff like gramoxone that is the only herbicide that has a skull and crossbones on it, that if it kills us and we're more microbial than we are human, is probably killing our soil microbiology too. So yeah, there's a lot that goes into that, but really it's just a lack of diversity, the lack of soil armor, and the lack of just being able to build an aggregate.
Great response, David. Does anyone else want to chime in on Janet's question there? She has another really good question. Go ahead, Gabe.
I would just add to that. Often what we're seeing working with clients, it is a lack of diversity. It is over application of synthetics. Remember carbon nitrogen ratios that if we're over applying nitrogen, doesn't matter whether it's synthetic or, in the case of manure from some of these confined animal feeding operations, we're going to throw off that carbon nitrogen ratio, and that biology is going to consume the carbon in the soil aggregates. That collapses the pore spaces and leads to lower water infiltration, leads to that compacted soil.
That's a great point there, Gabe. And we need to make sure the affinity for that nitrogen's tremendous for that microbiology. And as Gabe just stated there, just to make clarification, so when a bacteria takes 1 bite of nitrogen molecule, it's going to take 3 to 5 bites of carbon. So we got to keep that in mind. When their affinity for that nitrogen is so vast, they're going to be the first feeders on it. Then they're going to go consume carbon. So Janet's next question is regarding animal integration. Is there a formula for how long you can let animals graze on one patch? and how big that patch has to be per pound of animal. Also, how long the patch has to rest before animals can be on it again.
Mm-hmm. So again, context, you got to take into account your context, your ecological context, where you're at. But realize, given adequate moisture and sunlight, a plant will start to regrow within 3 days. So if you're going to leave them on a particular paddock over 3 days, you're at risk of that animal coming back and taking another bite off that plant. When it does, it prunes those roots, as we discussed earlier, and pretty soon that plant, you do that repeatedly, that plant will die, and then your perhaps less desirable species will start to dominate in that pasture. On our ranch, we move livestock every single day during the growing season. During the dead of winter, we move them a little less often. But we, in our environment, have found that we typically need to give 12 to 15 months before the plant's fully recovered. Now, down south, Dr. Alan Williams in Alabama, Mississippi, he likes to go, at least 90 to 120 days. We often see people who are moving them every 30 days. Realize that very few plants, if any, can recover in 30 days. So how big an area? That depends on the production of the plants. And we do have formulas. We do have materials available on our website, which can help show you as to the formula, how to figure out how big an area you need, depending on how many animals, their size, what species, etc.
Now to the question, I'm not sure what illustration, but I think the answer is going to be no. Was this vegetation irrigated? There wasn't any irrigated photos we had in any of our presentations.
Not a single photo in this presentation was irrigated. Yeah.
So I'm going to go on to William's question. It's a little lengthy one, so bear with me. I am a manager of a cattle ranch in a brittle environment, northern Nevada, mostly rocks and grass for grazing. I have been doing holistic management for a decade. I have watched all the webinars on your website. We have been following the 6 ecological principles. I believe the 4 processes are working for us better than our chemical neighbors. We see measurable success with high Brix readings in our forages and some drought tolerance. I am struggling to see how to stack enterprises to make more income in our operation. We have a very low population to direct market other products too. Do you have any marketing ideas? Thank you for all you're doing.
Great question, William. I would have to know more before I could recommend stacked enterprises, but immediately what comes to my mind, you said you have a cattle ranch. Is it possible to run sheep on that ranch? Is it possible to do some hunting enterprises, some ecotourism, things like that? Different ways to stack enterprises. Obviously, you don't have the grain, so I'm not going to recommend hogs. I'm not going to recommend poultry because that would require purchased inputs. We don't want to do that. But William, if you would want to email Kathy at understandingag.com, she can get me your contact information, and I'd like to find out more. I'd be happy to visit with you about it.
Absolutely. Adam, you have a question on here. If you would reach out to Kathy Richburg, our partner and director of operations for Understanding Ag, she can get that question answered for you on consulting. Donald has another question here. Gabe, what was the infiltration rates of your lawn when you mowed and fertilized? And what is it now that you moo with cows?
Well, Donald, to be honest with you, okay, I never did fertilize the lawn. That was a no-no. My wife hated mowing the lawn, And so her goal was just to mow it as short as possible and get it to go dormant as quickly as possible. We never watered it, never fertilized it. I did not take infiltration rates on the lawn, but I will tell you this, we have done it on our cropland fields. In 1991, when we purchased the ranch, NRCS did a suite of tests, and they found our infiltration rate on our cropland at that time was 1/2 of an inch per hour. And now Dr. John Norman 2 years ago used a dual head infiltrometer, which is a machine that it balances barometric pressure, wets the soil, then re-wets it, measuring infiltration rates, and we're over 30 inches per hour now. So we went from 1/2 inch per hour to over 30. There has never been a year in recorded history in Bismarck, North Dakota, where we have received 30 inches of precipitation in a year, let alone in an hour. So people can argue with me about that figure. I just sent it to Dr. Norman. All I know is any raindrop that falls on my ranch, with the exception of on a road, is going to infiltrate.
So Janet has another question here for us. In the Pacific Northwest, farmers say they can't do no-till without chemicals because we get too much rain here in the off season. What would you say to encourage them to transition? Well, I'll start this off and I want David to chime in also, please. So basically one thing is, I'm sure most of these producers are spending a significant amount of wealth income on buying herbicides to suppress what we call early successional plant spores, or most people refer to as weeds. So when we start building armor on the soil surface, we start inhibiting a lot of that weed seed from germinating. We got to remember weed seed has a pretty low starch component. So basically once it germinates, it's got to capture sunlight pretty rapidly. So if I have armor cover on that soil, I'm inhibiting that. Now also what I'm doing with that process, and Gabe brought this up earlier, is now I'm starting to provide a habitat for a lot of beneficial organisms such as insects, and research by Dr. Jonathan Lundgren starting to show a lot of these insect species consume a significant amount of the weed seed bank. And David, I'm going to allow you to go ahead and explain a little bit more what's occurring and how to start.
Yeah, so in those high rainfall moisture environments, the living roots are something that's out there growing, is actually utilizing the moisture. It's sucking up that moisture in that soil profile. It's helping to build the aggregate so you can actually put water deeper into that soil profile and infiltrate it rather than just sitting saturated on the surface and muddy like what a typical no-till field would be. The other part of this, the question that I see is to do it without chemicals. And, we talk a lot about regenerative ag, and nothing about regenerative ag is just without herbicides or without fertilizers or anything like that. Regenerative ag doesn't take the tools out of your toolbox. That's basically going to the organic route. And so we're not tying anybody and saying you can't do that. When we talk about limiting your disturbance, both physical, biological, and chemically, it's being able to reduce the amounts that we're using there as well.
Great points, David, and stuff. So William's got another question here. I am growing a 5-acre vegetable garden. I want to convert it to a no-till cover crop system. I have an 80-day growing season between spring and fall frost. I already grow cereals with daikon and mustards in the fall and winter, but what covers can I grow as companions in the growing season, in between the rows of potatoes, carrots, onions, peas, corns, beets? Can I just mix most of these species, except for corn, for pollination, to get the diversity the soil needs, or should I add other species? Gabe, what are your thoughts?
So I'll take a stab. So what we do in our garden is my rows are monocultures, but then I alternate rows with cover crop species. I like using species such as buckwheat, borage, annual flowers, oats. Have a variety of different species between those rows of your vegetables. There's a book out there, Carrots Love Tomatoes. You can read that book. It kind of talks about which species of vegetables do well around other species. But what we've found is if we have that diversity between the rows of vegetables, it really attracts the pollinators and beneficials. And I would say it's best to use what grows well in your environment, annual flowers, things like that.
Absolutely. So Donald has a question here. Is the way to get access to a report including all the tests you have run on the different farms so we can tell others? So I'm not sure what test. I'm assuming the water infiltration test. Donald, if you can contact us. We also do a lot of different Haney soils tests, phospholipid fatty acid testing. We do total nutrient extraction testing. You can go to our website and click on resource page, which should have all the reports to fill out to send those tests in.
I think, Shane, what Donald's looking for is, in order to tell others about this, do we have any compiled data? And Donald, we are working on that at this time, compiling the data across many different farms and ranches.
Apologize, Donald, I misinterpreted your question. Zach has a question here for us. He says, thank you for doing a series of webinars. Has already been a huge benefit for me. Would you consider a subsoiler or keyline plow a version of a mechanical disturbance? Does this disturbance the soil, live mycorrhizal fungi that much? Wondering if it would be beneficial for a farm we are trying to transition from corn bean with frequent tillage and a hard pan 6 to 8 inches deep. From constant disking the last 50 years. We planted turnips and radishes in our cover crop this year, but seems like they are having a hard time breaking through that hard pan with their taproot. Thanks again. David, I'm gonna let you be batter up. I think we all want to take a swing at this one.
Yeah, thanks again. So, I've had situations where I have ran a subsoil ripper on in-rows, where semis loaded, or there was a lot of compaction there, in the past, but I followed it with I had a cover crop already there growing before that, but to answer your question, really, I've also had, let me go back and another story, I guess, but one of our farmers out here in Kansas with this wheat project had an incredibly hard field where I couldn't even put a spade in the ground a year ago this past spring. And after he did his wheat harvest, he thought he'd go in with a subsoiler after he planted his cover crop to try to break and fracture that hard pan, and he couldn't get the subsoiler in. So we just abandoned that, let the cover crop grow, planted another cool season cover crop into that, plant milo into that this spring, and you can literally go out there now and stick a spade in the ground with little effort. So just by using those living roots and that diversity of crops, plus the diversity of the warm season cover crop followed by a cool season, and keeping that that soil covered, we can heal that soil really quickly. But it goes back to that one slide about how intentional are you, doing just that turnips and radishes, those tuber type plants really don't break up compaction as well as the fibrous grass roots do. And plus, if that is the only cover crop that's planted, that will actually increase your compaction because they're a low carbon to nitrogen ratio plant. And as they break down in the wintertime, those microbes are in need of carbon, and those species were actually, sequestering nutrients from the soil profile. So as the microbes are eating those, they're needing carbon. So now they're taking carbon from the soil structure and they'll collapse your soils. So, there's been a lot of bad advice out there, I guess I should say, about cover crops and what they can and can't do. And some people are putting together some very poor mixes for people that is not advancing their soil's health. It's actually going backwards. So if it were me, you know, I would be, if this is a row crop situation, corn bean, I'd be adding a small grain in there and following it with a warm season cover crop. It's hard to build a lot of soil health in just a corn soybean rotation. You really have to add that small grain in there so you have that opportunity to add that big, diverse, warm season cover crop to capture as much carbon as possible. And you have so much more growing days there.
Well, you hit that one out of the park.
Yeah, I would just, very good, David. I would just add to that David's exactly right about these cover crop mixes. People tend to have some bad experiences with cover crops. The cover crops are going to do what they do. The issue is, as David stated, we often put too many brassicas, too many legumes into these cover crop mixes, and then they tend to have negative ramifications if used in excess. So we need to be very careful of that.
Absolutely. Gabe, can you repeat the pest, insect / beneficial ratio?
Yep. And as Dr. Lundgren stated to me, for every insect species that's a pest, there are 1,700 that are either beneficial or indifferent, meaning they won't help you or they won't harm you. 1 to 1,700.
It's pretty good odds, isn't it? I take those every day. Amy has a question here. Can you discuss cost of cover crop seeds and the return on investment? Many farmers in my area, central Idaho, say the cost doesn't pay for itself. What are some areas of a balance sheet or expense should we be looking at for return on investment? And do you produce your own cover crop seeds or purchase them?
Want me to take the first swing, then I'll ask David or Eric to step in.
Yep.
So first of all, Amy, the biggest return on investment is not going to come immediately from your balance sheet. Where it'll come from is the benefit to the soil, as we described. Building soil aggregates, improving water infiltration, improving water holding capacity, increasing biology. One of the first things our understanding ag consultants do when going on a farm or ranch, we take a Haney test, we take a PLFA test, and we take a total nutrient digestion test. That shows us the amount of both inorganic and organic fraction of nutrients and the biology you have. Is that biology bacteria, protozoa, nematodes? What's the fungal component? That's where you'll see the difference. Farmers, you know, nobody is telling them to do that. They're simply looking at income and expenses and realizing they're taking their advice from an agronomist. That agronomist is unfortunately not telling them the fact that there's this much nutrients in the soil, the fact that they need to enhance their biology, the fact that if they do, they can start cutting back on synthetic nutrients in many cases just by following the Haney test recommendations. So they need to understand a lot more. Once they do, it is a pretty significant improvement in bottom line. David and I worked with one client this past spring. They saved $570,000 on their fertilizer just this past spring. David?
Gabe, if this was a game show and I had a little buzzer like I can hit, I'd have beat you to that answer. I've been waiting on this one. I read this one earlier and I'm like, I've got so many different stories I can tell. So we actually just did a video and we uploaded on YouTube last week with a young man out here in Kansas. And this is a really cool story. So last year it was wheat and half of the field he did a double crop soybean on. The other half he did a warm season cover crop followed by a cool season cover crop. This year he planted corn onto it. Now, last year it got really dry out here, so the double crop soybeans did not make any money, I promise you. It actually cost more money to plant it, harvest it, spray it, all that. So take that into consideration, because he had seed costs in for 2 plantings of a cover crop out there. Went out there, planted corn, treated the corn on both sides the exact same. And 3 weeks ago, they went in and started harvesting corn. And they started where they had the double crop soybeans. The corn was dried down to 16% there. And they got to where the warm season cover crop was. And the corn was 26% moisture. They had to stop shelling corn. They waited 2 weeks and came back in and finished it. It was back down to about 20 or 16% by that time. There was a 46 bushel yield increase to the cover crop side. So you can see that. Again, if you're intentional, you can see those results the first year. Go back to the story with the plow earlier, the keyline plow or the strip till or the subsoil ripper. And that farmer, we actually had a field day out there this morning, and I begged him to leave a 0 check of no fertilizer, 1 round in the field. And he had been, the rest of the field, he applied 80 units of nitrogen as a blend of like ammonium sulfate, 1034O, and 32%. And so his Haney test was showing a significant improvement in soil respiration, water extractable organic carbon, and even the Haney nitrogen was showing about 36 pounds of nitrogen. But he had in his cool season mix cereal rye, hairy vetch, and winter peas. He got nervous about the cereal rye taking up a lot of moisture at the 1st of May. Hadn't been any rainfall, so he went in and he sprayed out the cereal rye, and I had to bag him to let the legumes continue to grow to express themselves, because the 1st of May, those things were tiny. And so we waited. 30 days later, he came in to plant that, and it was a complete solid mat of purple flowers everywhere. So a couple of days before planting, he went in, he pulled a biomass sample of that cover crop just to see what the nutrient level was in that. We got that back after planting, so he didn't know what the levels of nutrients were going to be, but there was 140 pounds of nitrogen in that biomass at 3 tons an acre. So on that strip where he had, on that one complete round where he had no nitrogen, we go out there today, not a single person, out of almost 30 participants in this field day, could pick out where the 0 pounds of nitrogen were. Now, nitrogen since December has doubled. And in the last 30 days, it's went up another 25%. It's not getting any cheaper. So if we can sit there and look at our balance sheet and price out how much fertilizer it's going to cost, but if we can understand how to manage these things in our soils and in our cover crops and understand carbon and nitrogen ratios and how to make this work. And in Idaho, you could use a cereal grain or something else, bring in some livestock, graze it, take some economic advantage on that. You can make some significant returns this year. And as far as the second part of this question, producing your own cover crop seeds or purchasing them. So, that just depends on the farmer. And, it doesn't take a lot of acres to raise your own seed, but, knowing what you can raise in your environment, but then also having a cleaner and everything to be able to clean it as well. But I recommend if a farmer can raise it, to raise it. Seed supply is only getting tighter, and the cost of seeds is only going up, especially with freight and everything else.
The other thing, David, by raising and growing some of your own cover crop seed, it adds diversity into your own rotation.
Bingo.
Well, so many other things we could talk about. We got a lot of questions here to get through, guys. I'm just talking about raising your own seed, but Mark has a question here, and David, let you answer this real quick. Been having trouble finding a used roller crimper. Is there a better way to terminate cereal rye without a roller crimper? Example, mowing with a shredder has not proven effective.
Yeah, mowing's not going to work. unless it's completely at antithesis. Mark, I don't know where you're located at either. We talk a lot about roller crimpers out there, in environments like up in Gabe's area, the roller crimper just doesn't work because you have such a short growing season. So that's kind of more of a southern environment thing. Finding a used roller crimper is incredibly hard. I'd say to watch, auction time, tractor house, stuff like that. Every once in a while you can see them. The I&J, they're kind of building them on order, but they're behind. Progressive Ag Innovation is out in Northeast Kansas. They're building some as well. They're trying to keep up with demand as much as possible. If it's just cereal rye though, depending on the rate, you can actually use like a rolling harrow basket and roll it that way, as long as you're at antithesis or just past antithesis to roll it down. That'll work too. I've even seen guys roll it using that tool to roll it down, even using vetch in there. But you just have to watch where the bearings are and everything. Some other guys are taking the Yetter stalk devastators, mounting them onto you can mount it onto a planter if you got the right type of planter, or just on a separate frame and using that. Don is making some row units that you can mount onto your planter as well, that roller and crimp as well. It just, what gives you your flexibility. There's a lot of different options out there. Reach out to us, we can help you more.
Great response there. There's a question in regards to what soil test, and Eric, I'm gonna let you ask this one here. Would you recommend, we're talking about a large garden area, Brian is, what soil test would you recommend and use, and where can they get that done at?
Thanks, Shane. And one real quick, David took all my thunder, but I got to say that what was grown out in Kansas, that grain sorghum was also grown on 6 inches of rain that he didn't make. So mention, want to put that in there too. As far as the soil test, whether it's big or small, we recommend the Haney test for everything as a good starting point. Haney with a PLFA, if we can, the Haney test is going to show you what kind of biology you've got going, what we need to do. It just gives you a good starting point. We're going to use it on our garden or whether we use it on our big pastures. So, and I believe, Shane, can't they contact Kathy to get going on that, where they can get that done with Lance?
Yeah, well, you can go to our website and go to the resource link and click on that, and we have sample forms and sampling information there where they can print off a text sheet from Regen Ag Labs and fill it out to send their soil in with their soil sample. So,
and also if they want to reach out to us after we get that back to help them, kind of interpret that, what it's all about, we'd be glad to do that as well.
Absolutely. Thank you, Eric.
Mm-hmm.
So Nate asks the question, when transitioning to soil health principles from a highly conventional, and he was referring to tillage system, how do you balance minimize tillage passes and getting cover crops established? Do you go straight to no-till drilling? When does a tillage pass make sense? Okay, I'll let you start off with this one.
Some of the best advice I ever got was when I went no-till back in 1994. I had a friend of mine, northern part of North Dakota, who was a no-tiller. And he said, Gabe, the best advice I can give you is when you move to no-till, sell all of your tillage equipment, then you're never tempted to go back. And I actually did that. I sold all my tillage equipment and we have not tilled once. Tillage makes sense in no circumstance. Now, yes, if you go in and harvest a crop and really tear the field up, I would say that your soil health isn't in order and you should have just waited rather than tearing up that field. But it's realized if you start down this path, no-till a few years and then go in and do one tillage pass, you're back to square one. You've destroyed that soil structure. We can literally, in some circumstances, many circumstances, see a tillage pass easily 10 years later. So it's something that unfortunately you just don't want to do. So I would encourage people, if at all possible, go to 100% zero till, be intentional, and stay there.
If I may, real quick, I've got several clients that, on the size of acres, and they switch from, they're in the transition phase from conventional tillage to no-till, but they have a tillage tool. And so what they did, you have to be careful on what type of tool you have, but like a Great Plains or something where you can adjust the pitch and everything. If you can put a seeder on that, it actually makes a pretty decent seeder. But when you run that, I want the culture blades that have the most wave. I don't want a lot of disturbance on that soil. I don't even want to see the stalks of corn or soybeans, the roots being flipped up. I still want to see the tire tracks basically from that VT machine behind the VT machine after it's made a pass. And, it can seed covers pretty well, or if you're having the co-op come out there and spread it and use it that way to get started, that's fine. But if you can get rid of all that iron, you can buy a pretty dang nice drill, no-till drill as well.
Good point, David. So Kyle, so who are some academic researchers that focus on effective grazing practices, such as adaptive multi-paddock grazing, in a more brittle environment? Well, I haven't given him any heads up here, but Professor Alejandro's on the webinar this evening. And Alejandro, could you address this question? If not, we will.
Please go ahead, Shane.
Let me reread the question to you. Who are some of the academic researchers that focus on effective grazing practices, such as adaptive multi-paddock grazing, in more brittle environments?
Yeah, I think the way we have done in northern Mexico and other places in western US is actually from the ground up, from ranchers to ranchers, from actually showing the talking between ranchers. So it's not really something that is very academic, but it's something that just grows and shares between ranchers, the knowledge. And with all the tools that we have right now, all the internet and all the messaging tools, it's been facilitating the communication and the transfer of information with the ranchers.
Thank you, Alejandro. Gabe?
Shane, I would just add, you can look at some of the work Dr. Richard Teague did at Texas A&M. Dr. Teague did quite a bit of work on grazing in those arid, semi-arid environments.
Absolutely. Thank you, Gabe. Gabe, on your triticale vetch mix that you say is the most profitable cash crop, how many pounds of vetch do you plant per acre, and can it choke out the triticale if you get too much vetch?
Yeah, realize it's a combination cereal rye, winter trit, forage winter wheat. Now I've added winter barley to that mix. And I typically, in my environment now, realize it's going to change depending on your context, your moisture, etc. I like 70 to 80 pounds of the cereals and 12 to 15 pounds of hairy vetch if I am going to harvest that for seed. If I'm not going to harvest it for seed, I will back off on the hairy vetch. Absolutely, if you get moisture, the hairy vetch will pull down all the cereals. But what I'm finding is that, in our semi-arid environment, we're able to go in there and combine it and they'll be just fine. We're able to pick them up and get it harvested.
Thank you. Donald has a question. What material would you recommend for an infiltration test ring? 6-inch tubing with 6-inch in diameter. He's asking, would you use PVC steel, and how many inches would you test? So we want to make that infiltration ring at least 6 inches in length, 6-inch in diameter, 6 inches in length. You can use PVC, but you want to bevel the bottom so it can drive into the soil. If you can find a piece of 6-inch irrigation pipe that seems to work well, I have seen people use metal that's fairly thin, like off of an auger, that's 6 inches in diameter, use as an infiltration ring. Or also, we do have infiltration rings that we do sell that are very, very sturdy. Just be conscious of whatever you make it out of, you know, driving those into the soil that you don't break them, you know, when you do it. So make sure you get something fairly sturdy, and you want to put it in the soil 3 inches deep to do your water infiltration test. And this is based off of some research NRCS has done on this infiltration ring test that we utilize ourselves. So is it okay to graze more intensively right before winter, frost, snow? Okay, what are your thoughts?
Yeah, I would say absolutely not. And the reason being, fall of the year, as temperatures start to dip, that plant then is setting up its growing points for the following year. You do not want to be grazing that more right at that time, or you will cut back on your production the following year.
You're absolutely correct, Gabe. Molly asked a question. What is your experience with weed management in your system? Do weeds still seem to be a problem? I'm sure she's addressing it to you or me, Gabe, but
yeah,
let's go ahead.
Yeah,
I can go.
I do not have any weeds on my farm. We have a lot of forbs, but we don't have weeds. If livestock will eat it, it is not a weed, it's a forage. Okay, so it's a change in mindset. The minute you start saying one thing is bad and others good, you've kind of lost the battle. Realize that we do not use very much herbicide at all. As a matter of fact, last year, my entire herbicide bill for my 6,000 acre ranch was $19.95. My wife was harassing me about a patch coming up the driveway. So I couldn't get livestock there. So I bought something just to get rid of that patch. But it's a non-issue because Shane mentioned it, granivores. Granivores are insects that eat weed seeds. There's some really good work by Dr. Randy Anderson, ARS Brookings, South Dakota, that he did some work on what percentage of weed seed bank is eaten by insects. And then if you're using no-till, not disturbing, and as Shane said earlier, have that armor on the soil surface, it really isn't much of an issue. Besides, I would just add briefly, any weeds that are seeds that are combined, we run all our grain through a quick cleaner. That's the perfect feed for our poultry rations.
Go ahead, Alejandro.
Yeah, thank you, Shane. That actually goes along with the in rangeland, in southwest or the western states with the sagebrush or the mesquite, where I think we're always battling with those woody plants, spending a lot of money on fighting those woody plants. But I think that was nature's response to trying to cover the soil with something that cattle cannot eat, period. Because I think that we recently actually measured the temperature on bare ground at the ranch. I think the air temperature was like 85 at that point at 10 a.m. And on bare ground, it was like already like 100 degrees. And under a creosote or a woody plant that we may see it as undesirable, it was 75 degrees. So I think nature figured out a way to cover the soil with something, and nature, we have to see nature as always helping us. So why would I actually kill all those woody plants that they are seen as displaced in the grass, but that's not the way it is. We just need to be patient because, for example, in my ranch, the grasses are actually killing the mesquites and all the woody plants. It's just that we have to understand that the timing is just nature's time. it's not our time. So we need to be patient on that.
Points, Alejandro. Thank you. Maggie's asking the question, is hairy vetch / cereal rye an okay mix for cover crop seeded into soybean stubble going into corn next spring? David?
Yeah, if it's going to corn next spring, that's a great mix to do. You know, you want to balance the amount of, you know, cereals and the legumes in there to balance your carbon to nitrogen ratios. We would want to probably look at a Haney test first to see what your CO2 respiration is, so we can understand how active your soil microbes are, to identify what the ratio of this needs to be. You know, and depending on where you're located at, Maggie, we could probably maybe add a couple other species into this mix. And also depends on when that soybean is going to be harvested as well. You know, realize, you know, if one of your goals is to get the nitrogen value out of that, hairy vetch, really, by the time it starts putting on any biomass, you get a lot of big nitrogen benefit for, you know, the Midwest, central part of the Corn Belt and all. You're looking at mid to late May. So you still get good benefit out of it. It's just how much will you get out of it?
Shane, I think Maggie's question, a little confusing there. It appears to me by reading it that what she is asking is hairy vetch, cereal rye, an okay mix for cover crop seeded into corn going to soybeans.
Ooh.
Okay. And
that
would not be the case.
No. We want to go more carbon, because what did we just take out? We took out a very high legume plant. So we've provided a lot of nitrogen to the system. So what we need to provide now is abundance of carbon, because that biology, the bacteria, are going to consume that nitrogen. Then they're going to start consuming aggregate structure if there's no carbon being supplied.
Yeah.
So what's going to happen next spring? Go ahead.
Right. No legumes prior to soybeans.
Exactly. The biggest problem there too is legumes produce their own nitrogen. So if you're putting a legume out there, you're feeding nitrogen to a legume, and by the time it's setting pods, it didn't nodulate well because it had excess nitrogen in that soil profile. That's why the cereal rye is there, to take up that excess nitrogen that might have been there from that previous corn crops fertilization program. And so you're actually going to hurt yourself on yield.
Great points, great talking points. Thank you for the question, Maggie. August Hortzman has a question here. You showed a picture of a trampled, diverse summer annual mix. You were talking about keeping a living root. With the heavy trampled field, with the majority of the plant material laying over, is there still living root? And I think the picture he's talking about, Gabe, is your sorghum sedan there.
Yep. And realize, August, I should have given some context there. First of all, yes, there's still a living root. If there was ample moisture, that would regrow those species in there. In that particular photo, that is my protocol prior to corn, because I'm going to go lay down that amount of carbon. We're going to get a frost shortly thereafter. Those are grass finishers on there. And we're going to have a frost. And I need that much armor to cover the soil. So when I plant corn into it, I can do it without any herbicides the following year. I use winter as one of my unfair advantages. It'll kill about everything up here. And so we will have a very good amount of residue to plant our corn into. But that's a good question, August.
Absolutely. I'm going to do a few more questions here and call it a wrap. So we're going to rapid fire here. I'll put a 10-way cover crop mix into my wheat stubble the 1st of August, but are seeing a lot of tree seedlings starting up. What can I do to prevent these trees from starting? David, you want to tackle that one real quick?
You know, it just depends on what trees they are. And a lot of times in straight no-till systems, we'll see a lot of trees starting to come into them. You know, we use weeds as kind of an indicator. I'll use that weed term, I guess, as an indicator species of what our soils might be lacking as well. And so, you know, sometimes we're going to have those tree species show up just because that soil is lacking something, or maybe it has an excess of something as well. You know, and like I said previously, if you have to use a little bit of herbicide to take it out, that's fine. If it's not a lot, just go out there and clip them off too. If you got a cow, use a cow.
Great points. Abra's got a question here, and I see you responding to him, David, online, but you say this could, we're going to talk about this. You say this can be applied anywhere in the world. I am in Central Florida. My property is sand, scrub oaks, and sparse grasses. It has been untouched for 30 plus years. Have you seen anyone use these methods on land like mine? I've been told by local farmers that it's not worth it, that soil cannot be regenerated. Well, I will disagree. You know, first thing, we've got to start implementing the principles and put them in place. You know, how much armor do we have on that soil surface? Obviously, you're in a very probably humid, moist environment. So you're going to cycle a lot of carbon rapidly. So obviously, we've got to start building some armor. You know, how much diversity do we have in that system? You know, this is a system where animal impact is going to be extremely important. To utilize a lot of that vegetation, to trample down some of that vegetation, but also to help stimulate some of that latent seed bank that may be there in order to start adding more diversity. So that's a great question. And my response is absolutely, it can be accomplished, especially in your environment. So we got to understand the principles and how do we get these processes working within your landscape. Gabe, you want to add anything before we move on?
No, you covered it.
So Doug has a question here. I've been doing no-till for multiple years, utilizing diverse cover crop mixes and integrating livestock as well. When will I know I have enough biological activity to eliminate the use of commercial fertilizers? David.
First off, I'd be taking a Haney soil health test and identifying what you actually have going on in your soil profile. Couple that with maybe a PLFA test so we can identify your fungal to bacteria ratios and what activity there we have. But ultimately, I'd be doing some zero check strips. I mean, 0 pounds of NP and K, and then maybe do half rates of each one of those individually. So you can see, are you taking an economic gain from applying that fertilizer or not? Or is it actually costing you money? You know, that's the quickest and easiest way. On-farm trials on your own farm.
Great point, Dave. That's what we encourage everyone to do, start doing your own farm trials, testing in order to build confidence. Lynn asked a question. What cover crop would you recommend in Southwest Saskatchewan? Usually, I'm assuming talking insufficient rain, July, August, for a warm season plant to grow much. Gabe.
Yep, I'll take this one. Lynn, you're kidding yourself if you think a cover crop's going to grow if it's extremely dry following a cash crop harvest. What I would do is diversify the rotation a little bit and go to different cash crops, whether it be some fall cereals, early spring seeded crops such as peas, lentils, oats, barley. And then I would also take a percentage of the acres if possible and go to a diverse cover crop mix. You didn't mention if you have livestock or not, but if you do a very diverse cover crop mix, such as millets and that seeded in early June after the last chance of a killing frost is typically passed. You can add cowpeas or regular peas to there, get some diversity into the system. But after the cash crop is harvested, I would just let grow what would let grow. And oftentimes what we do is we just open up the sieves on the combine a little bit and blow a little out the back. And that becomes our cover crop if we get moisture to germinate it. And typically you get enough doing that to germinate some of that.
Thank you, Gabe. Lewis has a great question in the webinar with here. Is hairy vetch toxic to cattle? No. Now, let's talk about this. You know, first thing, it's the reason we advocate utilizing diversity. You know, in order that diversity is going to help allow those animals to select their diets much better. You know, and if we stop and think about this, a lot of monocultured plants can be toxic. Even brome in my part of the world can be toxic. You know, fescue can be toxic, but when they're in a monocultured systems. That's the reason why we encourage diversity within these systems. And Gabe, would you like to follow up any longer with this?
Sure, I get asked this question a lot. You know, I've been grazing hairy vetch since 1995. I've grazed thousands of head of cattle on it, never had an issue. But as Shane said, it's always with diversity. I know of only two head. One gentleman lost 2 head to the sensitivity issue from hairy vetch, but 2 out of hundreds of thousands. And yet we have researchers and those out there saying that it's toxic. You simply need to ask those who are saying that if they make their living running livestock or not.
Great deal. So first thing, I want to thank everyone for attending this evening's webinar. Fantastic questions that we had. Just a reminder, we have our upcoming webinars, Ranching for Resilience by Alejandro Carrillo, coming up October the 28th at 7 p.m. Central Time. So anyhow, on behalf of Understanding Ag, myself and Gabe Brown and all the consultants, thank you very much. Take care. Bye.